Good morning, students. Today we'll start a new chapter, Force and Pressure. In class 7th, you learned how objects move. Do you recall how you can decide that whether an object is moving faster than the other? What does the distance moved by an object in unit time indicate? That is speed. Last time we have learned about speed, velocity, and other all things. This chapter we learn about force and pressure. Everything else we know in the previous class that for some objects to move, we need force. We need to apply force. And also to stop a particular object also we need a force. To stop a particular object also we need force. Both are very important. Now, why do you think a moving object like a ball rolling on the ground slows down? Or sometimes it may change the direction of motion also. It is also possible that ball may slow down and also change its direction. Do you know what makes the ball to stop or to become slow or to go faster or change its direction of motion? See, the surface on which the ball is moving, it may be a cement floor or it may be some rugged, some other floor, tile floor. Each and every floor applies a force called as frictional force. When we apply force, the ball moves, but continuously the floor in the opposite direction will be putting a force called as frictional force. The frictional force makes the ball to stop. Like when we have to move, no, we have to overcome a force called frictional force. We stop. If we stop, the frictional force and the force which we are applying will be equal in magnitude or equal in their power. Like this is what you need to understand. Frictional force is the force which makes a ball to stop or to change the direction. These all are nothing but what is then force, student? Force is an agent which makes an object to move faster, slower, stop it, or also change the direction. Everything we require force. Force is such an important agent. Let us recall some of our everyday experiences. What do you do to make a football move? What do you make a moving ball to move faster? How does a goalkeeper stop a ball? How does a hockey player change the direction of the moving ball with a flick of a stick? How do fielders stop a ball hit by a batsman? In all these situations, the ball is either made to move faster or slower, or direction of the motion is to be changed. Like told here and all, to stop a ball, to make a ball move faster, to change the direction of a ball, in all the aspects we have to change, we have to apply the force. To apply the force. That's why this will change. We often say that the force applied on a ball when it is kicked, pushed or thrown or flicked. What is a force? What it can do to the bodies on which it is applied? We will find out the answers. Force is nothing but a push or a pull. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change, state of motion of an object. Can these terms be replaced with one or more terms? Like we will find out. In science, a push or pull on an object is called force. If you push something or pull something, then it is called as a force. Thus, we can say that the motion important to objects was due to action of force. That means force makes the object to move, or even it can help you to stop. Also, it can move faster, change direction, etc. There are different kinds of force. Forces due to an interaction. Suppose a man is standing behind a stationary car. Will the car move due to his presence? No. The man has to push the car. That is, he applies a force on it. The car may start to move the direction of applied force. Means it will move in the direction where in the direction in which he is applying force. Note, the man has to push the car to make it move. In figure 7.3, two girls are playing. Can you decide who is pushing and who is pulling? In these cases, both the girls appear to push each other, while both girls in 7.3b is trying to push each other. Similarly, the cow and the man appear to pull each other. The girls in two situations shown here are applying force on each other. It is also true for man and a cow. From these examples, we can infer that at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object results in the force between two objects. Like I've been told, like this man pushing a car, two girls pushing each other, and two birds pulling each other, and here cow and a man. In these all things we know that force is applied. It may be push, pull or some other thing, but it is applied. So for force to come into play, we need minimum two objects. With one object we cannot bring force into play. We require minimum two objects for force to come into play. We require two objects for force to come into play. Very, very important. You can observe these examples now. See, here he is pushing the car. Both girls are pushing each other. These two girls are pulling each other. The cow is pulling him and man is also pulling the cow. For force to be applied, we require minimum two objects which are interacting with each other. We require minimum two objects to pull each other. Exploring forces. Have you ever seen a game of tug of war? In this game, two teams pull at a rope in opposite directions. Members of both teams try to pull the rope. This is called tug of war. Tug of war. Members of both teams try to pull the rope. Sometimes the rope simply does not move. Is it not similar situation shown in the figure 7.3b? The teams that pulls harder, that is applies a larger force, finally wins the game. What is this? These two examples show. Two examples show for you. Force applied on an object in the same direction add to one another. Let's recall what happened when you and your friend pushed the heavy box in the same direction. If two forces act in the opposite direction, the net force acting on it is the difference between two forces. If two forces are applied on an object in the same direction, they add. But if they are applied in opposite direction, they differ each other. They are try to cancel each other. Like in a tug of war, clearly the force is applied but in opposite directions. So at this time what happens? The total force will be the difference between these two forces. But if you apply the same force on both sides, same direction, if force is applied, then the forces add up. The net force is the addition of those two forces. Recall the tug of war. Tug of war, when two teams pull equally hard, the rope does not move in any direction. In tug of war, if the two teams apply equal forces, then the rope does not move in any direction. So we learn that a force could be larger or smaller than the other or equal to each other. Strength of the force is usually expressed in its magnitude. The force can be larger also, smaller also. Strength of the force is usually expressed by its magnitude. We also have to specify the direction in which a force acts. Also, if the direction or the magnitude of the applied force changes, its effect also changes. Next, a force can change the state of motion. A force can change the state of motion. Change the state of motion. You might recall some situations. For example, while taking a penalty kick in a football, the player applies a force on the ball. Before being hit, the ball was at rest, so its speed was zero. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. The force applied by him cannot stop or deflect the ball, saving a goal being scored. The goalkeeper succeeds in stopping, the speed decreases to zero. These observations suggest that the force applied on an object may change its speed. If the force applied on an object is in the direction of motion, the speed of the object increases. If it is applied in the direction opposite, then it decreases the speed of an object. A force can change the state of motion. Motion is what? Nothing but speed. Like for example, if you see, if a footballer kicks the football, before the football was at rest, it was not moving. Now it will start to move at some speed. This shows that the force can increase the speed and make the object to move. The same moving ball, if somebody tries to apply force like goalkeeper in the opposite direction, the ball stops. So here also the force can be used to increase the speed also and decrease the speed also. But if the force is applied in the same direction as of the object, then it increases speed. If the force is applied in the opposite direction of the object, then its speed decreases. Once again, I will be telling, if the force is applied in the same direction as the object is moving, then the speed increases the speed. If the force is applied in the opposite direction of the moving object, it decreases the speed of the moving object. It decreases the speed of the moving object. Speed of the moving object. Paheli is curious to know whether application of force can only change the speed of an object. Let us find out. Let us consider for an example, game of the volleyball, player often pushes the moving ball to their teammates to make a winning move. Sometimes his ball is returned to the other side of the court by pushing or smashing it. Cricket, a batsman plays his or her shot by applying a force on the ball with the bat. Is there any change in the direction of the motion of the ball in these cases? All these cases, the speed and the direction of the moving ball change due to application of a force. Can you give few more examples? A change in either speed of an object or its direction of motion described as change in states of motion. Thus, a force may bring a change in state of motion of an object. It does not mean that application of a force will always result in a change of state of motion. It is common experience that many times application of force does not result in a change in the state of motion. For example, heavy box may not move at all if you apply maximum force that you can exert. Again, no effect. The force is observed when you try to push a wall. Sometimes even when the application of force may not result in change of state of motion. Today we were discussing about force and pressure. Like I told, a moving ball stops on the floor because of frictional force applied by the surface. It can make the ball to stop, slow down, and even so force is something which can change the direction, which can increase the speed, decrease the speed, change the shape, change the size of an object, etc. What is force? A push or pull is called as force in size. A push or pull is called as force. A push or a pull is called as force. Next is, if the forces are applied in the same direction, the forces add with each other. and the net force is total forces which are acting the same direction. If the two forces are applied in opposite direction, then it is the difference of forces, and it is the difference of forces. Like in a tug of war, if both teams apply equal equal force, then the ball does not move. Then the probe does not move at all. Forces can be big, forces can be small, etc. The force can change the state of motion. Like before I have told, again by applying force we can make an object to move faster. For example, a football kick. And by applying force we can also decrease the speed of an object. For example, goalkeeper can make the ball to stop also. This is what we call as force applied. Force is, in the basic sense, it's an agent which changes the state of motion. What is change of state of motion? Either increase in the speed or decrease in the speed, then we call that is change of state of motion. So apart from this, even force can change the size, shape of an object also. By pressing, we can change the shape of a ball. We can change the size of a ball, shape of a ball also. So force has a lot of these uses. But in general sense, force is a push or a pull. Force is push or a pull. Force is push or a pull. Forces require interaction. For example, a force for interact requires two bodies. Then only the force will come into play. The force cannot come into play in case of a single body, because by applying force we need two objects. One object which is applying the force and another object upon which the force is being applied. Like you see the man pushing the car. The man is one object, car is another object. So he is applying the force on the car. So two objects are required. We cannot bring the force into play with only one object. With one object. Next, if forces are applied in the same direction of moving, then it adds. Otherwise, a force can change the state of motion. A force can change the state of motion. A force can change the state of motion. A force can change the state of motion also. State of motion also. A force can change the state of motion. ಸೊ ಸಿಂಪಲ್ಲು ಫೋರ್ಸ್ ಹಾಕಿದ್ರೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಸ್ಪೀಡು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೋದು, ಡಿಕ್ರೀಸು ಮಾಡ್ಬೋದು. ಒಂದು ಆಬ್ಜೆಕ್ಟ್ನ ರೆಸ್ಟಿಂದ ಮೂವ್ ಮಾಡ್ಬೋದು, ಒಂದು ಆಬ್ಜೆಕ್ಟ್ನ ಸ್ಟಾಪು ಮಾಡ್ಬೋದು, ರೆಸ್ಟ್ಗೂ ಕರ್ಬೋದು. ಸೊ ಈ ಫೋರ್ಸಸ್ ಇವೆಲ್ಲನೂ ಮಾಡುತ್ತೆ. ಎ ಫೋರ್ಸ್ ಕ್ಯಾನ್ ಇನ್ಕ್ರೀಸ್, ಇಟ್ ಕ್ಯಾನ್ ಡಿಕ್ರೀಸ್, ಇಟ್ ಕ್ಯಾನ್ ಮೇಕ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಟು ಮೂವ್, ಇಟ್ ಕ್ಯಾನ್ ಮೇಕ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಟು ಸ್ಟಾಪ್, ಇಟ್ ಕ್ಯಾನ್ ಮೇಕ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಟು ಇನ್ಕ್ರೀಸ್ ದ ಸ್ಪೀಡ್, ಇಟ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಮೇಕ್ ದ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಟು ಚೇಂಜ್ ದ ಡೈರೆಕ್ಷನ್ ಆಲ್ಸೋ. ಇಷ್ಟೆಲ್ಲ ಫೋರ್ಸ್ ಮಾಡುತ್ತೆ. ಫೋರ್ಸ್ ಏನೇನು ಮಾಡುತ್ತೆ ಅಂದರೆ ನೋಡಿ, ಎಲ್ಲ ತಿಳ್ಕೊಬೇಕು. ಫೋರ್ಸು ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಮಾಡುತ್ತೆ, ಸ್ಟಾಪು ಮಾಡ್ಬೋದು ಮತ್ತು ಮೂವ್ ಮಾಡ್ಬೋದು. ಸ್ಟಾಪಲ್ಲಿ ಆಗಿರೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ನ ಮೂವ್ ಮಾಡೋದು, ಡೈರೆಕ್ಷನ್ ಕೂಡ ಚೇಂಜ್ ಮಾಡ್ಬೋದು. ದ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಈಸ್ ಮೆಜರ್ಡ್ ಬೈ its magnitude. The amount of force is measured by something called as magnitude. The amount of force is measured by something called as magnitude. Called as magnitude. These objects can change the state of motion. Change the state of motion. ಫೋರ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡ್ರಲ್ಲ, ಫೋರ್ಸು ಏನೆಲ್ಲ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳಿದೆ. ಬಾಲ್ ಸ್ಟಾಪ್ಸ್ ಆನ್ ಎ ಫ್ಲೋರ್ ಬಿಕಾಸ್ Force can make an object to move or stop, and force can make something to stop also, or something to move also. Force can change size, shape of an object also. Change the size, shape of an object also. Sometimes even by applying force you may not get any result. For example, if a box is very heavy, apply force, it will not move. Now it does not mean whenever force is applied it will result in some kind of motion or movement. Sometimes it may not result kind of movement also. It may result in any kind of movement also. So it's very, very important. Forces applied on an object in the same direction add to one another. Force applied in opposite direction will cancel each other. That is, they become difference.